Section 1.4, Radical Equations, Part 4. This is a topic that appears in our section on radical equations. Solve equations in quadratic form. So these are equations that look like a quadratic but aren't quadratic. We're going to use a method called substitution. It's used to transform an equation to a second degree equation. Recall, a second degree equation has the highest power on x, or on the variable, is 2. Okay, here's an example. Notice why they call this an equation in quadratic form. It kind of has that look of a quadratic. And in fact, if I could substitute a u in there and call x to the fourth u squared, then x to the second would just be u, then I have a quadratic equation to solve. So that's the idea behind this. So we're going to let u be equal to x squared. And if that's the case, then u squared is x to the fourth. So now we get the same green equation we had before by substituting u in the place of x squared. And now we'll factor that. U minus 4, u minus 36. We'll solve. U minus 4 equals 0, so u is 4, or u is 36, right? 36. Okay? And this, now that we've done that, of course, that's what u is equal to. We're solving for x. So now we go back and substitute again. We put our x squared back in for u. X squared equals 4. X squared equals 36. Square root method to solve these quadratics. And we get plus or minus 2 and plus or minus 6. So this was not a radical equation. It's the radical equations that might have an extraneous solution. So we don't have to worry about extraneous solutions in this problem. So our solution set, -2 and 2, -6 and 6. Let's look at another example. Notice how this one also has that quadratic look about it. We've got some expression squared, and then we have it to the first power. Let's get it in that sort of quadratic form. And then let's let u equal s plus 1. If that's true, then u squared is s plus 1 squared. Replacing now using u substitution, this is our new equation that we have to factor. So we'll use the grouping method of factoring, where we look for two integers whose product is a times c and whose sum is b. How about -25 and 1? Okay, so we'll break up our 3-term polynomial into a 4-term polynomial using -25 and 1 for the middle term. Now we'll group and factor. Now we'll set each factor equal to 0 and solve. Okay, so this is what we got for u, but u was equal to s plus 1, right? So s plus 1 equals 5, s plus 1 equals -1/5. Solve for s. Okay, again, this wasn't a radical equation. We don't have to worry about extraneous solutions. These are our solutions.